In this video, we'll explore the dynamic modifier xpSplash. We'll look at setting up crown splashes which affect fluid sims. We'll use it in conjunction with the xpSheeter and explore how to modify the look. In this scene, we'll set up a couple of different uses of xpSplash. So first of all, we have a water tank bit of geometry. There's also a floor. Let's just disable that floor for now because we don't need it. And we have this, which is basically a cube with the top face removed. Has an xParticles collider tag with the collisions set to the normals inside, which means that the particles can be captured within its volume. And this is going to be our water tank, and we want to fill this up with fluid. So let's get an emitter. So we'll go to the emitters tab here, and we'll create a new emitter. We'll go to the object tab, and we'll select a box emitter, and let's just pull this out. So it's roughly the same. Now, we could obviously do this perfectly, but let's just eyeball it. So we'll pull these knots out, and so it has the same dimensions pretty much as our water tank. There we go, and hit F1 to go back to our perspective view. Then obviously we need to move this emitter up, so we'll move it up somewhere like that. Let's reduce the height, something like... maybe slightly bigger, something like that. Okay. And what we want to do is shoot out particles on one frame and one frame only, and then they'll fall into our container. So we'll go to the emission tab. We'll change the emission from rate to shot. The shot time is on frame 1, and it'll last for one frame, so it just shoots out once. And by default, it's set to random, and you put how many particles you want to shoot out. But we don't want that. With fluids, remember, we want nice, even distribution of those particles, nice spacing. So we will choose the shot type hexagonal. And the hexagonal shot type, the amount of particles you get is dictated by the particle radius. The bigger the radius, the fewer particles can fit within the grid, so you'll get less. And the smaller the radius, the more particles can fit in the grid. So let's just take that speed away, hit play. And there we've got a decent amount of particles in there with the default radius of 3. So we could actually perhaps, look, let's put this radius up to 5, just so we get some fewer particles, which means quicker playback. All right, and there they are. And if we hit play, they're not doing anything, obviously, because we have no modifiers in the scene. So let's add what we need to make this fluid. Well, first of all, we need some gravity. So we'll go to modifiers, motion modifiers, and we'll pick a gravity. And we hit play. And they all fall to the base, but obviously they're not interacting with each other yet, the particles. They're just all individual entities. So let's go to Dynamics, and we're going to use the XP Fluid Effects for the Fluid Solver. Let's click that, hit play, and now we have a fluid sim. It's a little bit difficult to see the way this is moving because we got the dot display type. So let's go to the emitter, display, and we'll change the editor display from dots to squares. And let's give these kind of a dynamic colouring. So instead of them all just being this single colour, we'll change that to gradient parameter. And now it's going to map those particle colours based on, not their age, based on, let's pick speed. So it means the slower particles will be coloured blue and the lighter particles will be coloured white. And then we need to put what we think will be the approximate maximum speed. We'll just guess at 350 for now. And now if we hit play, you'll see we're getting a little bit of colour change as those particles are animating. All right, so there we have our fluid. So let's make this a little bit easier to see. We can make our water tank invisible. And let's go to our emitter, to those display settings, and let's deactivate draw emitter. And all that will do is it won't draw the bounds of that box emitter. So now we can see everything more clearly. Let's make that gravity invisible as well. And now we've got a really clean scene to see what's going on. All right, so now we have got this water tank full of water, we can now start investigating the xpSplash object. So let's go to our dynamics menu, and we will go into the menu, and we can pick an xpSplash. Let's click on that. And we get this interesting looking object coming into our scene. And what this is a dynamic modifier, which is basically going to blast our particles in all of these angled directions. It's actually quite simple what it does, but it's very effective. So let's play this scene. And you can see straight away, look, even with it up here, it's starting to suck up those particles and shoot them out, and then it stops. So let's have a look at exactly what's going on here. If we have a look in our xpSplash settings, there are some obvious settings like bottom radius is the radius of the bottom part. The height is obviously the distance between the bottom and the top radius. The top radius adjusts this section. We can adjust the number of handles. So at the moment we can see that, look, we have a handle here, and if we follow that handle up, it has another handle at the top, and all of these have these handles that protrude upwards, and by default we have that set to 8. We can increase the amount or we can decrease the amount with the handle number. We'll explore that a little bit more deeply in a bit. We have a strength value, we have a start time, and then how long it's going to be blasting for. So by default, it's starting right at the beginning on frame 0, and it blasts for 30 frames. So if we pull this down closer to the surface of our fluid, we want it to blast. We want a time for this water to settle. So let's put the start time at, say, 30 frames. And let's give it a, let's just give it a 1 frame blast. See what happens. So our water settles on frame 30. We get a tiny little ripple because 1 frame just isn't enough to blast up these particles. So let's increase that to, say, a 20 frame blast. Let's have a go. Bang. And there we're getting a blast, and we're already getting something that looks a little bit splash-like. Interestingly, if we increase this duration to, say, 500, the entire duration of our scene, watch what happens. It's just continually firing up these particles, and look, they're kind of getting sucked in, and we are gradually emptying the tank. And they're going and going and going to the point where they aren't close enough to get sucked up anymore. All right, and it's an interesting effect. We can, of course, move this around, and it's almost a bit like a tornado coming along and sucking up all of this water out of our tank. So it's a very basic object, really, what it is doing. It takes the particles, we design the shape of it, and it blasts the particles up at those angles depending on the strength settings that we put. And that is it. But obviously, there's an awful lot we can do to tweak the look of these splashes that we're getting. Let's just have a quick look at distance and fall off before we move on and set something up a little bit more specific. So if we hit play, you can see that we're getting particles being drawn in, and they're moving, and they're getting quicker and quicker and quicker to the point where they're at that bottom radius, and then they get pushed up at full whack into our splash shape. And the reason that's happening is because of this distance value and the fall off. So what the fall off is saying is, over 20 centimeters, which would be this x-axis, 20 centimeters, at 0 centimeters, so actually on that radius line, they will have full power, and it will gradually wane off as it moves away from this point. And we can see that, look, if we increase that distance to, say, 70, look, they're getting pulled up much, much closer. And you can see, look, instead of that blast of particles just hugging this line, it's moving out, and there is a 70 centimeter fall off of its strength. If we bring this more into a more kind of narrow band, then it's a much thinner stream. It's hugging the shape of our cone more. And if we, let's increase that again to that large amount and bring this fall off right across, we're going to get big lumps of water all being fired up with the same strength. So for most use cases, you would keep your fall off with this curve, and then you can make your adjustments with distance for how wide you want the effects of that to be and how thick you want that stream. And this strength fall off is actually a deprecated feature now, and this fall off doesn't do anything. So ignore strength fall off. Okay, so those are the very basic functions of our xpSplash. It's a simple modifier that kind of creates this force which blasts these particles, and we can adjust how those particles are blasted with the various different handles. So we won't explore those now. What we will do is move into a different scene, and we'll set up a very specific type of kind of crown splash. We'll bring in the xpSheeter as well, and then we will start using these handles to art direct our splash to get the precise look that we want. So what we're going to do is we're actually going to get rid of our water tank, because if we just go forward one frame, we've created this simulation where if we wanted to make a crown splash, we have simulated a whole kind of container full of water just to make one small splash. And that means that when we are coming to kind of tweak our xpSplash and change these handles and try and art direct the shape, we're having to simulate every frame this big large container full of water, which is going to be inefficient. So what we're going to do instead is create some fluid particles that are born just very close to the start of our splash, create the splash as kind of a self-contained simulation, and then once it's done, we can then integrate it with a larger tank simulation so it interacts with it and it looks like it's within one scene. So let's go to our water tank, and we'll just go to the collision tag, and we will deselect enable collisions, so that's not going to interfere with anything. Let's activate our floor plane, which has a collider tag as well. And let's just go to our xpSplash. We'll go to the coordinates and we'll just right click here just to zero out those coordinates. Excellent. All right, and then in the emitter, what we will do is we will go to our object tab, and we had this set as a box. So in fact, look, let's put the display draw emitter back on so we can see the outline. So we had this as a box to fill our tank, but now what we want to do is create some particles in and around the base of our xpSplash modifier. So the shape we're going to pick for that is going to be the torus, which will be perfect for us. Let's just go to coordinates and zero out the coordinates of the emitter. So then what we want to do is we want to kind of increase the size of this torus so it is kind of surrounding this inner radius. So I've adjusted the outer radius of the emitter. Let's make that a bit thinner. All right, there we go. Something like that. And now we're going to have particles being born within this volume, which are surrounding the bottom radius of our xpSplash. So let's just take that splash and the emitter, and let's just raise it up a bit so that emitter is above our floor just. There we go. So now if we hit play, you're going to see that we've hardly got any particles. And that's because we've made a very small volume compared to that big water tank. And within this volume, remember our particles, if we go to the emission tab, are 5 centimeters in radius. So in hexagonal emission mode, you just can't get more than this amount of particles within this volume. The only way to get more is to reduce the size. So if we put this down to, say, 2 centimeter radius particles and go forward a frame, now we've got lots more particles to play with in our scene. All right. So now if we go to our xpSplash, let's just have a look at those settings because we can make a couple of adjustments. First of all, we can get this to splash immediately on frame 1. And let's just get it to splash for, say, 10 frames for now. So it's just like a blast of force, which then stops. We'll put our distance just back to the default 20. So let's hit play and see what we get. So we're getting a little bit of a spurt. Now, one thing you may notice is we're getting one big kind of ring of particles and then a few stragglers, but our sheeter is going to struggle to fill all of this in. So what we would like is with our base particle to have a bit more of an even distribution. So the way we're going to do that is go to our emitter. We'll go to the emission tab and we will, instead of shooting them out just on one frame, let's do it over, say, 5 frames. But this is going to cause an issue. If we press play now, you're going to see that we're going to get a bit of a kind of an explosive blast from the bottom of this ring as well as from the splash. Let's have a look. Yeah, so we're getting this kind of this bulbous explosion. And the reason we're getting that is it's to do with the fluid solve. Now remember, on frame 1, we're emitting particles and everything's fine and fluid effects is going to work out the fluid density and then do the velocity solve after that. However, on frame 2, we have had the same amount of particles again suddenly appear within virtually the same volume. So that means that the fluid density is going to be a lot higher. That's going to cause a pressure, which means we're going to get this kind of explosive blasting force. And we don't want that. But we do want to kind of pump more particles into the scene. So the way we get around it is we go to the XP Fluid Effects and we use the Check Density option. And what that does is, for every new particle born, it checks the density, and if it's born in a position and a state, which means its fluid density is over 110% of the overall fluid density in the scene, then it just gets killed, and it prevents that blasting of particles. So if we hit play, now that's gone, and it's much smoother, and we're getting this bit of a blast. All right, we could even emit for maybe 7 frames, and if we go to our xpSplash, 10 frames, yeah, let's have a look. All right. So there's our splash. Now, let's have a look at bringing in the sheeter. And once we've started sheeting these particles, we can then look at manipulating the handles within our xpSplash to get different looks. So we'll go to our dynamic menu. Let's go to our dynamic objects and bring in an xpSheeter. And we're going to disable velocity alignment because we're not interested in the angle at which particles are moving away from each other just yet, just as we're setting it up. So let's hit play. And we may have 1 or 2 sheeted particles there, but not a lot. Now remember, the sheeter is looking at 2 separating particles, and if they're moving away from each other in a way that satisfies the various different checks that we put, like min-max density and min-max hole size, then it fills in the gaps. At the moment, not many of the gaps are being filled in, and that's because we're only saying particles with a very low density amount are allowed to be sheeted. So if we increase this, you're going to start seeing, look there, straight away, it's filled it in, and we've got a completely filled in sheet of particles. Let's just reduce that a bit. There we go. And that's splashing down. All right, so we'll make some further adjustments to that sheeter, but for the start, you can see that we very definitely have got the start of a crown splash. All right, so let's have a look at our controls in xpSplash then. If we click on it, it reveals the various different handles. So what we have, if we just dolly in, you can see that on the bottom radius, we have a handle here. If you follow the line up, it reaches another handle here, which can be moved. And both of those handles have Bezier controls, so we can change this shape. Okay. Not only that, the handle then continues up until this line, which can be moved up and down. So what these controls do is this. The two bottom handles change the shape of the crown splash and therefore the shape of the animation and how the particles are moving. And the top handle controls the strength of this part of the splash. So let's demonstrate just adjusting the strength first. Now what we're going to do is, if we hit play, you can just see that we've just got a perfectly, well, pretty much perfectly round splash. Let's say we want some point to this crown splash. Well, the way in which we're going to do that is we're going to adjust the strength of these points. But before we do, let's just give ourselves a few more handles. Let's put this up to 12. And what we're going to say is this. We're going to bring this one down and the one next to it up. Okay. And then we're going to bring this one down, this one down, and the one next to it up. So we're adjusting the strength of these parts, these areas of the modifier by changing these handle strengths. And what we're going to do by this is create some nice spikes, some peaks and troughs. Right, bring that one down. And then we're back where we started. So now you're immediately going to see something that's obviously less regular. Let's hit play. And you can see those spikes appearing now. Look at that. Excellent. Let's move this one up a bit. So we've got a little bit more movement from those. There we go. So that's looking pretty cool. So obviously we don't necessarily want the spikes to be this prominent. So let's just move up our bottom points a bit so the difference isn't quite so great. Move those up. Move it up. Move it up. Let's just have a look at that. There we go. So now you can see we're getting some spikes. So that's pretty cool. Let's just make some so they go really high and really blast up. Whoosh. Okay, so now we've got a little bit of a difference in power along our xpSplash. We could make a couple of adjustments to our sheeter to give some cool effects. Now at the moment, every particle is sheeting and we're getting this continuous sheet of fluids. But let's say we want some water droplets to be escaping from the faster bits. Well, the way we can do that is go to our xpSheeter. We can put in a relative speed check and we can reduce this down. So it's saying you're allowed to sheet particles that are moving away from each other within 0 to 230 centimeters per second difference, but anything faster than that won't be sheeted. So let's see if that's enough. Yeah, well, that's too much. Look, they're all escaping. So let's increase this up. Still a bit much. Increase it up. So now we're getting some water droplets escaping from the top of those splashes. All right, very cool. Let's keep it moving. And then it splashes down. Very nice. So I'm pleased with that. We've adjusted just the strength. So just by adjusting the strength of our handles on our xpSplash, we have created a lot of variation in this. We've created some nice crown spikes. And then by putting this max speed check in, we've managed to separate out some water droplets that are moving too fast to be sheeted. So that's looking pretty neat. All right, what else may we do? Well, let's have a look at adjusting the shape now. So what we'll do is let's hit F5 to go to our orthographic views, and we'll pick this top view here. So we'll maximize that, select our splash. So what we have here is, remember, we have our handles here affect our position. So we're going to adjust some of the outer radius handles. So let's take this one and move it out that way. Let's take this one, move it out there. So we're kind of creating a bit of a flower effect. by pulling these out. Where are we? There we go. I've messed that one up, haven't I? Move that one back. Move this one out. And then we'll move that one out. All right. And then if we just hit play with this top view, you can see that, look, we really have managed to sculpt it in exactly that shape that we have designed by moving those handles. If we hit F1 to go to perspective view, now we've created these nice curves into it. Look at that. Really cool. So obviously we could adjust our bottom radius points as well. But for now, I'd like to leave that because we want the particles all emitting from our torus, which matches obviously the radius, the perfect circle, the radius of that bottom part of the xpSplash. So another couple of things to note here. If you are in perspective view and we say want to move some of these handles, they'll move in 3 dimensions. But let's say you just want it to move in the same direction as the strength handle. Well, if you hold shift, then it will do that. You can stretch it up and down and it's only going to move in that direction. It's restricted. If you let go of shift, it can actually move in all dimensions that you wish. So obviously there is just ultimate artistic control here. We've got Bezier handles as well for each of these points, so all of those can be adjusted as well. So you can effectively get any shape that you want from this splash. We've got a pretty uniform 6-pointed crown here, but let's say that you want to kind of direct the splash in a specific direction. Well, that would be pretty simple. All we'd do is, look, let's just reduce all of these power handles on one side. Let's bring them all down. And then let's just try it at that for now. So now we're just going to get them blasting over it this way. We've got our blast of particles. If you want that to be more pointed, you can of course direct them like so. And you've got 2 blasts coming out with the faster one separating because of that speed check we put in the sheeter. And that's looking really cool. So the xpSplash modifier is a very simple modifier in what it does, but it works to create some really nice complex looking simulations, and obviously should be used in conjunction with the xpSheeter and with a fluid solver. XP Fluid Effects would be my go-to fluid solver for its versatility, but of course you could use this with XP Fluid Flip as well, as long as your scene would fit within the XP Fluid Flip domain. But for the most versatility, use it with XP Fluid Effects for these fantastic crown splashes.